Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's video we are going to see few examples based on difference amplifier and subtractor. So let's begin with the topic. Now in this problem we need to design a circuit which is having gain of 10. So first write down an output equation. So VO is equals to 10 into V1 minus V2. Now in this circuit, from the output equation, we will come to know that the output is nothing but difference between two input signal and having gain equals to 10. So from the equation, we will come to know that the circuit is nothing but the circuit of difference amplifier. So first, let's draw the circuit of difference amplifier. So here we are having two input signal V1 and V2. Let's consider this is resistor R1, R2, R3 and R4. So we know that the equation of difference amplifier is given by VO is equals to RF by R1 into V1 minus V2. Now here value of RF by R1 is given as 10. So we can write RF by R1 is equals to 10. In the circuit diagram we are using R2 as RF and R1 as R1, which is equals to R2 by R1. Now if we consider this equation, R2 by R1 is equals to, now we know that the value of R2 and R4 is same because both are considered as RF only, and R1 R3 is same because both are considered as input resistance only. So the same R2 by R1 can be written in the form R4 by R3. So now we have R2 by R1 is equals to 10. So let's assume R1 equals to 10 kilo ohms. So if we substitute the value of R1, we will get value of R2 as, so R2 is equals to 100 kilo ohms. So if we put the value of R2 and R1 in the equation, we will get output equation VO is equals to 10 V1 minus V2. So from the relation R2 by R1 equals to R4 by R3, we can get the value of R3 as well as R4 also. So let's write down the values in the circuit diagram. So value of R1 is considered as 10 kilo ohms, R3 is also 10 kilo ohms, R2 obtained as 100 kilo ohms, and R4 is also 100 kilo ohms. So in this way, by using the output equation or a gain factor, we can easily calculate the values of resistors that can be used in the difference amplifier so that we can get the desired output as required in the problem. Now let's move to the next problem. The statement of the next problem is design and draw circuit for VO equals to V1 plus V2 minus 2V3. So in this case, we are having two operations, that means addition as well as subtraction. So first, let's write down the output equation, which is VO equals to V1 plus V2 minus 2V3. Now first concentrate on the first two terms, that is V1 plus V2. This is nothing but the adder, so we can write, consider V1 plus V2. So in this case we are going to use VO1 is equals to minus RF by R1 into V1 plus RF by R2 into V2, which is equals to minus RF by R1 into V1 plus V2. Now the equation is similar. Now let's consider value of RF as 10 kilo ohms. So assume RF equals to 10 kilo ohms. Now if we compare the two equations, that means the equation number 1 and equation number 2, we will come to know that RF by R1 is equals to 1. So RF by R1 is equals to 1 and RF by R2 is also equals to 1. So from this we will get value of R1 as RF is 10 kilo ohms upon R1 is equals to 1, and 10 kilo ohms upon R2 is equals to 1. So we will get R1 as 10 kilo ohms and R2 also as 10 kilo ohms. Therefore R1 is equals to R2 is equals to 10 kilo ohms. Now the next thing in the output equation is VO is equals to V1 plus V2 minus 2V3. This is what the output equation. So we have already obtained the value of R1 and RF for V1 plus V2. Now next thing we need to consider minus 2V3. So in order to obtain that we need to consider inverting amplifier. Therefore the equation becomes VO2 is equal to minus 2V3. Therefore consider inverting amplifier. Therefore VO2 is equals to minus RF by R1 into V1. Therefore minus RF by R1 is equals to 2 minus 2. Therefore RF by R1 is equals to 2. The negative sign indicates that the input is applied to the inverting terminal of the op-amp. Now previously we have considered that RF is equals to 10 kilo ohms. Therefore 10k divided by R1 is equals to 2. So here we'll get value of R1 for inverting amplifier as, therefore R1 is equals to 5 kilo ohms. So now if we combine two outputs, that means VO is equals to VO1 plus VO2. VO1 is the output obtained from adder circuit and VO2 is output obtained from inverting amplifier. So we will get VO as V1 plus V2 minus 2V3. Now here we need to draw a circuit diagram also. So let's draw the circuit diagram. So first we'll draw the circuit diagram for adder. So this is adder circuit and this is inverting amplifier. Now let's draw the circuit first. The two input V1 and V2 is applied to the inverting terminal and non-inverting terminal is connected to ground. So this is A1. So here we will get VO1. For second we are using inverting amplifier. So this is your output VO2. Now both the input are applied to the subtractor because here sign present is negative. So this is RF, which is equals to 10k. This is also 10k as this is RF. This equals to 5 kilo ohms, which is R1 for inverting amplifier, and for adder circuit we are using two values, that is R1 and R2, which is equals to 10 kilo ohms. So this is R1, R2, each having value of 10k. We are using same values of resistor for a subtractor circuit, therefore values of RF and R1 remains R for subtractor. So this is op-amp A2, this is op-amp A3. So we will get output as V1 plus V2 minus 2V3. So in this way we can obtain the circuit, or we can design a circuit by using the given output equation. Now let's move to the next problem. The statement of next problem is, using op-amp obtain the given output VO equals to 5V1 minus 4V2. So first output equation, VO is equals to 5V1 minus 4V2. The same equation can be written in this form, that is 5V1 minus 20 V2. If we write the same equation in this form, the meaning of equation is remains same. So we can write as VO is equal. So from the equation, the term minus V1 can be obtained by using inverter. That means a amplifier having gain 1. Therefore we can write V1 can be invert by using inverter. So we can write as RF by R1 is equals to 5. Now let's assume value of RF as 10 kilo ohms. Therefore we will get R1 equals to 2 kilo ohms. Similarly, to obtain output as 20 V2, we get RF by R2 is equals to 20 as RF equals to 10 kilo ohms. So we will get R2 equals to 0.5 kilo ohms. So the circuit diagram for obtaining the given equation can be, first of all, we are using inverter. So input V1 is applied to inverting terminal, and then the output of inverter is applied to the second circuit. So for inverter, the values of resistor remain same, that is 10 kilo ohms. This is V2 and this is V1, or we can say VO1. This is value of RF. So we will get output equation as 5 into V1 minus 4 V2. So if we substitute the values of resistor, we can get the output equation VO as 5 into V1 minus 4 V2. Now let's move to next problem. The statement of the next problem is find output of the given circuit if R1 equals to 1 kilo ohms and RF equals to 10 kilo ohms. Now in this case, we need to find out the output equation rather than finding out value of RF and R1. The circuit is given and we need to find out the final value of output voltage by using various values of RF and R1. So first, let's see the circuit diagram. From the circuit diagram, we will come to know that the 3 op amps are used in different configuration. So we up to VO1 will consider circuit as first stage, up to VO2 will consider circuit as second stage, and then third stage. The third stage will give you the final value of output, that is nothing but VO. Now if we look at the circuit properly, then we will come to know that the first stage is nothing but inverting amplifier. So the first stage is nothing but inverting amplifier. The second stage is nothing but the stage of subtractor, as value of RF and R1 are remain same. So we can write this is as subtractor. And the third stage is nothing but a non-inverting amplifier, as VO2 is applied to the non-inverting terminal of op amp. So let's find out the output of first stage, that is VO1. As first stage is inverting amplifier, therefore VO1 is equals to minus RF by R1 into input V1. Therefore VO1 is equals to value of RF given in this problem is 10K and R1 is equals to 1K into V1. So we'll get VO1 as 10 V1. So consider this as equation 1. Now let's consider the second stage, which is nothing but the stage of subtractor. Second stage output, that is nothing but VO2. Therefore VO2 is equals to V2 minus VO1. So we will get V2 minus 10 V1. Therefore, VO2 is equals to V2 plus 10 V1. Now let's consider the third stage, that is nothing but non-inverting amplifier. That is your final output VO. So VO is equals to 1 plus RF by R1 into VO2, which is equals to 1 plus RF by R1 into V2 plus 10 V1. So we will get output equation as 1 plus value of RF is 10K and R1 is 1K into V2 plus 10 V1. So we will get VO is equals to 11 V2 plus 10 V1. So this is what the final output of the circuit which is given in the problem. That means VO equals to 11 V2 plus 10 V1, which is obtained by using three different stages of the circuit, which consists of inverting amplifier, subtractor and non-inverting amplifier. Now let's move to the next problem. The statement of problem is find the output voltage of given circuit if R1 is equals to 1 kilo ohm, RF is equals to 1.8 kilo ohm. The problem is somehow similar to the previous problem, but only thing is the value of RF and R1 is changed. So let's see the circuit diagram which is given in the problem. V1 is applied to the inverting terminal of the op-amp. Therefore, we can say, let's write down here as VO1. So till stage VO1, the circuit is similar to inverting amplifier. So this is first stage, which is nothing but inverting amplifier stage. The output of first stage is applied again to the inverting terminal, and we have second input V2 applied to the non-inverting terminal. So we can say the circuit is similar to the subtractor circuit. So till VO2, the second stage consists of subtractor, or we can say difference amplifier. And the third circuit in which VO2 is applied to the non-inverting terminal of the op-amp. So the final output, that means third stage, is nothing but the output of non-inverting amplifier. So let's find out the output by each stage. So let's consider stage 1. Output is VO1. Therefore, VO1 is equals to minus RF by R1 into V1. As the circuit is of inverting amplifier, RF by R1 represents the gain, and negative sign indicates that the input is applied to the inverting terminal of the op-amp. So value of RF given is 1.8 kilo ohms. So minus 1.8K divided by R1 is 1 kilo ohms into V1. So we will get VO1 is equals to minus 1.8 V1. So this is equation 1. Now this 1.8 V1 is applied to the inverting terminal along with the input V2. And the second stage is nothing but the stage of subtractor. So the output of the second stage VO2 can be given as VO2 is equals to V2 minus VO1. So V2 is the applied input minus value of VO1 is minus 1.8 V1. So VO2 is equals to V2 plus 1.8 V1. So this is equation 2, which is nothing but the output of second stage, that is difference amplifier or subtractor. Now let's consider the third stage, in which output of second stage is applied to the non-inverting terminal, and therefore the amplifier is similar to the non-inverting amplifier, and in that case the final output VO can be given as VO is equals to 1 plus RF by R1 into VO2, as VO2 is only input which is applied to the non-inverting terminal. Therefore 1 plus 1.8K divided by 1K into VO2 value is V2 plus 1.8 V1. So we will get VO equals to 2.8 V2 plus 1.8 V1. So this is the final output that can be obtained by using a non-inverting amplifier, which is nothing but the third stage of the given circuit. So in this way we can solve the various problems that can be based on the circuit, which consists of combination of difference amplifier, subtractor, inverting and non-inverting amplifier. So I hope you understand this topic. So thank you very much for watching this video. Stay tuned to Ekeeda. Subscribe Ekeeda. Thank you.